Alright, so good morning, Grayson. Alright, so this session or this recorded video is meant for the graphing, no? Graphing or the clarifications with regards to polynomial function. Alright, so for anything else, let us have this short opening prayer. Okay, so let's bow our heads and feel the presence of our Lord. So, Father, the Son, the Holy Spirit, Amen. So, Lord, we offer you everything we do today, all our words, our joys, and our sorrows. Everything will be an act of love for you. Holy Mary, Saint Joseph, Saint Joaquin, and Saint Anne, guardian angel, intercede for me so that I may be deserved to be held and safe today always. Virgen del Pilar, pray for us. In the name of the Father, the Son, and the Holy Spirit. Amen. Alright, so going straight forward for this record, no, we'll be discussing and clarifying things with regards to graphing polynomial function. No? Alright, so going back to graphing, no? Graphing a polynomial function, isn't it that we discussed about the uh, things that you should remember when you are to graph a polynomial. Okay, so we discussed that there are some indications, no, in order for you to know when the graph is racing or facing upwards or downwards, isn't it? Or is it going to the first quadrant or fourth quadrant, isn't it? So there is a table, isn't it? So this is a recap and a lesson, no, which we should be facing, no. All right, and from that table, isn't it that we discussed that there is even a positive and negative, there is even and there is odd. All right, so we said that if the graph, no, if the graph is facing, or if the graph of the polynomial expression or the expression or the highest degree of that graph, no, is odd, no, and the degree of that expression is positive, no. If it's odd and if it's positive, what we have there is that the graph of it is facing just like this, no. So the two ends of that graph is facing the initial end of that graph is starting coming from the second quadrant. Okay, this is the quadrants coming from the second quadrants going to the first quadrant. Okay, third quadrant going to the first quadrant. Okay, so if it's even, okay, if it's even, we said that the ends of this graph, no, is facing upwards. It's facing upwards. Okay. While when it is uh, when the graph is when the expression when the degree of that expression is negative and it is even, no, so we said that the graph or the ends of the graph is facing downwards. Okay, and if we say that when the uh, degree of that expression is odd and it's even, no, we say that the initial end of that graph starts with second quadrant and ends with fourth quadrant. So it starts in here until in here. Okay? Alright. And there is a, a, property where in having the degrees of positive degree, no? For example, if your uh, degree or your exponent or the exponent of your expression is positive, it always ends up with the first quadrant. And when the exponent of your expression is negative, no, it always ends with fourth quadrant. Okay, so I hope you remember these tables, no, and you remember those properties of that degrees. And also, I know that you could remember, no? You could remember about things that I mentioned that you should remember about the factors. Okay, factors, the roots, no? Roots and zeros. Okay. So what else aside from this one? Isn't it that I told you and I mentioned that you should remember as well graphing the ED. Okay. Next is the zeros and multiplicity. Multiplicity. Okay. All right. So with those with this thing, um, we will be graphing, no, a polynomial function, no, whether how would that function would be facing? Is it facing upwards or downwards, or would it be just like the zigzag, no, zigzag graph, no? So, but before that, let's go back to the basic concepts of expressions, no. So, if we are if you are going to have an expression of x, x squared, no, that is an expression. If you're going to multiply x squared to x, what would be the final answer? The final answer in here is x cubed. Okay? Or you can just simply, the exponent is cubed, isn't it? So that's the thing. Maybe some of you, I mentioned the things that are not meant. So that there's a confusion. It should be that the rule in polynomials, if it has the same, no, if it has the same variables, no, you can multiply it. But if it has different variables, for example, you have x to the cube or x cube multiplied by y cubed, the final answer is in here would be x cubed y cubed. Only that one, ha. That is the proper way around. How are we going to know the product of of an expression? So let's clear up things. No. So what if, no? What if you could have an expression, for example, or if you have confusions way back then, please erase that one. And this is the correct one, ha. So what if we have 4x squared multiplied by 4, okay, x squared. Alright. So these two factors are, or these two terms are expressions, isn't it? And with those expressions, they are just the same. So the question is, how are we going to multiply an expression if it has coefficient? So if we say that it has coefficient, we are going to multiply. This is the rule in polynomial. This corrections, confusions. No? So let us have this one. So if we have the polynomial, we have the coefficient and variable. Okay? So when we are to multiply, if you have a number, let's just say your number is 3, and you have an variable of x. If you are going to multiply, let's just say, you are going to multiply it, no, for the coefficient, what will happen to the coefficient is you're going to multiply. Okay? And when you are about to multiply a variable, you're going to add the exponent. Huh? But there is rule. we cannot add the exponent if it has different variables. That is the one, isn't it? That a while ago, x squared multiplied by y squared, no? Y squared. The final answer in here is that we just add them both. Like, the product will be x squared and y squared. Okay? But, if you have both x squared multiplied by x squared, the answer in here would be x to the fourth power. Okay? It doesn't matter, this is the thing. For the corrections and confusions, no? If you have any for example, if you have variable and you have any degree, you have 5, and you will be multiplying that one in uh, x raised to 4. The answer in here is that it will be raised up to 9. So what happens in your exponent is that you add the exponent. Okay, that's why we have add. Okay, but your coefficient, you are just going to multiply it. No, multiply it in what? Multiply it in a normal way. Okay, so if you have 4x squared, look at this one. If you have, if you have 4x squared multiplied by 4x squared, the answer in here is that we multiply first the variable, and the answer in here would be x raised to the fourth, no? And we multiply the coefficient. And if we multiply 4 times 4, the answer is 16. So we have 16x raised to the fourth power. Okay, so that is the one, But what if you have 4x squared multiplied with 4y squared? Okay, what do you think would be the final answer? Okay, what do you think would be the final answer? In that case, what are you going to do, no? Even though they have different variables, so what are we going to do in here is to multiply still. How are you going to multiply? The rules: variable to variable, coefficient to coefficient. So in here, if you're going to multiply x squared multiplied by y squared, the answer is x squared y squared. So if we are going to multiply both coefficients, what would be the final answer? The final answer would be, what would be the final answer? The final answer would be 16. So the final answer for 4x squared multiplied by 4y squared, no, is 16x squared y squared. Okay? Alright, so we are clear with that one, Alright, so now, if you have given a factor, for example, y is equal to the function of 2x squared plus 2x plus 2. Alright, so with this one, for example, let's say example, I will be asking you that in this function, this is a function, no? What is the highest degree of that function? What is degree? If you say degree, if you say degree, what is degree? Degree is our exponent. Okay? This is exponent also, invisible one, isn't it? So any variable has the exponent of invisible one. Not unless it will become squared, cube, no? Fourth power, okay, fifth power, no? So exponent is a degree. Now my question is, in this degree, what is our highest degree? We have, what are the terms? We have 3 terms, isn't it? So we have the first term, second term, third term. Now, from the terms, the three terms, what are the terms that has variables? Of course, we could only see the degree to those polynomial that has exponent or variables. Of course, because exponent cannot be cannot exist without a variable. No. Now, we could say that the first and second degree has a variable. Okay, so may I ask, um, for the first term, what is the degree or what is the exponent, of that expression? The exponent of that one would be 2. Okay, how about the second term? The exponent of the second term is 1. Okay, now, um, from these two terms, no, what is the term, what was the term that has the highest degree? Is it the first term or second term? First term or second term? Of course, the first term, because the degree of the first term has 2. Okay? So, in totality ha, I will be erasing this one. In totality, now my question is, from this function, isn't it that this whole function is a function? Okay? Now, from this function, what is the highest degree of that function? The highest degree of that function is 2. Okay? The highest degree of that one is 2. Simply as well. Oh, how about this one? Let's have another example. Y is equal to x cubed plus 3x minus 2. What is the highest degree of that function? Oh, this is a function, ha? This is a function. What is the highest degree of that function? Oh, the highest degree, how are we going to know? What are the degrees? Isn't it that we have the first term, second term, and third term? And only the first term and second term has the variables. And knowing that the variables consist of exponents as well, no? So they have the degree. So we could tell, no, that they have the degree. Now, may I ask you, from the two terms, the first term and the second term, among the two, which has the highest degree? First term or second term? First term, of course, because the first term has 3, no? The power of 3, or it is raised with cube, or 3. While this second term has only 1 degree, or 1 exponent. Okay, so we could simply tell that this function, no, the highest degree, okay, let me just erase, the highest degree of this function, the highest degree of that function is 3. Okay, the highest degree of that function is 3. How about this one, How about this one? X to the fourth power plus 2x cubed plus 2x plus 4. How about this? How about this function? This is a function. It has 4 terms already. Also, we have the first term, second term, third term, fourth term. All right. So, which among the terms has the degree? Has, Oh, the terms that has degrees or exponents are the first term, second term, and third term, isn't it? Now, if only the first term, second term, and third term has the degree itself, my question is, among the three, which has the highest degree? First term, second term, third term. The term that has highest degree is none other than first term, of course. The exponent or the highest degree of it is 4. Correct. Correct, ha? Alright. So, maybe with this 3 example, you know it already. How about this one? I'll be giving you a different example. What if your function would be x plus 2, x minus 2, and only this one. Okay. So in this case, um, what is your highest degree? In this function, what is your highest degree? Knowing that they are factors for the corrections and confusions that you've got, no? What is the highest degree? Okay, the highest degree in here is 2. Why is it 2? Oh, Sir Jai. Oh, if we have two factors in FOIL method, isn't it? FOIL method. FOIL method. If we say FOIL method, we have first. What is the first? First term. What is our first term? We have x's, no? So, if you are going to multiply the first term, it will become x squared. Okay? How about the outer term? Oh, our outer is x and negative 2. So, with that case, if you're going to multiply negative 2 by x, the answer would be negative 2x. Okay? Oh, how about the inner? Okay? If you're going to multiply, what's our inner? This is our inner, 2 and x. So if we are going to multiply positive 2 by x, the answer would be positive 2x. Alright. So how about the last? Or our last term, 2 and negative 2. Oh, positive 2 multiplied by negative 2, what will be the answer? The answer for that one would be negative 4. Okay. So in totality, if we're going to finalize this function, no? So we have x squared, okay, and we have negative 2x and positive 2x. So if you have negative 2x, when you add up with positive 2x, when you add negative 2x by positive 2x, the answer would be 0. Okay, 0 or none. Okay, it will be cancelled out. Okay, why? Maybe you're going to tell me why. No? So, seems like negative 2 plus 2, the answer is 0. Only that one. And the remaining, no? The remaining term that we have is none other than negative 4, of course. So, the final answer in here is that our function would end up with x squared minus 4. Now, my question is, what is the highest degree of that function? A while ago, we said it's 2. So, you could clearly say that the term that it has is only x squared, no? Alright, so maybe you will get confused. I'll be erasing this term. Okay? So, if you will notice, if you will notice, this is our factors, isn't it? So in those both factors, this is a easiest tip, no? Quick tip for everyone. Question yourselves in this first factor, isn't it that you have two factors, no? The first factor, you have x plus 2. Okay? Question yourself, in that first factor, how many terms do you have? You have x and 2, isn't it? So you have two terms. Okay? You have x and 2. So therefore, you have two terms. Now, my question is, among the two terms, which of them has the degree or the exponent? The x only, of course, because that is the variable. So, may I ask you, what is the degree or the exponent of that factor? The highest degree. The highest degree would be 1 only. Okay? So, same goes by to the other factor. What is the highest degree of that exponent? Oh, you know it already, for the first term and second term. The only term that has degree or exponent is the first term. So the highest degree in this part is 1. Okay. So both of them 1. In totality, they are in variables, no? Now, my question is, if you are going to multiply them, no? If you're going to multiply them both, in totality, the terms that they have is what? They have is 2. Okay. 2. Huh? Okay. How about this one? I'll be giving you another example. What if our function would be x squared, okay, plus x squared plus, let's just say this one. The function is x squared minus 4 multiplied by x plus 2 multiplied by x minus x squared plus 2. Oh, and with this one, oh, how are we going to know if this is in a factor form, isn't it? So me ask you, what is the highest degree of that function? That this is only one function, one function. Though you could see 3 factors. Those are factors only. But in totality, if we're going to multiply all that factors, we are going to end up with one function, no? So if we're going to multiply them both, if we're going to multiply these 3 factors, no, we will be ending up with how many? How many functions? We only have one function. Now, my question is, what is the highest degree of that function? A while ago, we talked about that one. Okay, if you see factors, no, if it's in factor form already. Now, if it's in factor form already, question yourself within the term of that factor, among them, which has the variable? Which among them, which has the variable? The variable the term that has variable is the first term only. Okay, the first term only, of course. Now, if we have the first term, okay, this is the highest degree of this first term is 2. Okay, so in totality, in the first factor, we have the 2. Okay, how about in the second factor? The highest degree of the second factor would be 1. Okay, how about in the third factor? The highest degree of the third factor is 2. So, in totality, if we are going to, no, if we are going to, add them all, how many exponents do we have? That's my question. How many? We have 5. Okay, so the highest degree of these, no, of these, the highest degree of this function is 5. Okay, it's raised to 5. Only that one. Okay. All right. So how about this function? X squared x to the fourth x plus 2 and x minus 2. What is the square? Okay, so with this one, so how are we going to know when, how are we going to know if this factors is in form of this one? No, so we say that we just look upon the factor itself. No, you just look upon the terms inside the factor. So we have the first term, No, we have the first term for the first factor. We have three factors. This is the first factor, this is the second factor, and we have the third factor. Okay. So, as I mentioned, no, we talked about that. We are going to look among the terms of that factor, the first terms and the second terms, isn't it? Now, my question is, in the first factor, what is the highest degree that it has? It only has 1 because it has only x, no? How about for the second factor? No? What is the highest degree of the second factor? The highest degree of the second factor would be 1 as well. Okay? But this is the question, no? If you're raising some. Okay. This is the question. How about in the third factor? You could see that there is squared. Okay? But this is my question. For that squared, um, my question is that how is it going to be? Are we just going to look just the same as what we did for the first functions that we discussed? Isn't it that we are going to look for the first term and second term? Or knowing that it is squared, what are we going to do in here is to square this whole factor. So knowing that it is squared, of course, it will come up with x minus 2 and x minus 2. Okay? So, in totality, the value of this factor, of the third factor, it is just like this. Okay? So, my question is now, for the third factor, what is the highest degree that it has? The highest degree of the third factor would be 2. So, in totality, for that full function, what is the highest degree of that full function? The highest degree of the full function is 4. Okay, so I hope that you can now analyze, no? With the terms that we need to uh, do, no? When we are to graph something else. Okay? Alright, so I will be preparing something. What if this is the thing, huh? Okay. So let us now go to this part. So let us go to the graphing part. No, we are going to what was this one? We're going to end with the graphing part already. So if you will remember, we have ED, zeros, and multiplicity. Multiplicity. Okay? Multiplicity. Okay? So, in that case, no, I will be questioning you, no? If I will be questioning you, um, if we say end behavior or EB, no, we could clearly graph a polynomial function, no, if if the end behavior is clearly seen already, no? So that is my tip. As I said to you that you should remember these three things, no? So look for the end behaviors, the zeros, and multiplicity. No? So for the end behaviors, if you have a graph, okay, okay, and you have a graph of this one, what did you notice about the graph? About the end of that graph. The end of that graph ends with first quadrant. And knowing that it ends with first quadrant, it only shows us that the highest degree, no, the highest degree of the polynomial function that we have is positive. positive. So, the degree of that expression is positive. Okay? Or the expression itself is positive. Now, what if you are given a graph just like this? Mhm. So, it is clearly seen, no, that when the end behaviors of this graph, no, falls with fourth quadrant, when it falls with fourth quadrant, we could it could shows us that it is falling within negative expression. Okay, remember in the table, this is our table, isn't it? So, this is our table. If we have negative, if we just saw negative, or if we just saw that uh, our 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 end behavior falls with downwards and it falls with fourth quadrant, we could say that the expression is negative. Okay? Alright, so we could clearly say that the expression is negative. Now, this is the question. How are we going to know if it's even or positive? No? This is the thing. We could clearly say that it's even when it shows in a manner that both ends are facing at the same direction, most likely in upper direction. But if it's odd, no, if it's odd, um, if it's odd, most likely, both ends are facing downwards. But there are times that the other side, the other end of that graph is at the upside down direction. Same goes by with the positive, no? But when we say positive exponent or positive or even exponent or odd exponent, we could clearly say that when it's even, it always ends with upwards, no? And uh, when it's uh, positive, when it's even, the end behaviors, no? The end behaviors of that graph, no, always fall with, it always starts, though, it always starts with upperwards, no? Up in the first quadrant, this is for this wait, this is for your even, this is your odd. If we will be putting just like this one, okay, this is your negative, this is your positive. Alright. So when it's even, you could clearly say that both ends are just facing. This is a clarification. When it's even, both ends are with the same direction. Okay, both upwards, both downwards. But it's odd. When it's odd, you could clearly say that it's in a S form or in a form of a zigzag. No, so now, having those even, no, we cannot clearly just tell what is the graph because we cannot just simply uh, say that it's even without the graph. Of course, you could have the polynomial function, no, given at you in order for you to graph. But if you have graph, no, we could play for example, if the problem was given to you only the graph, you could clearly say that the function starts with even if the two ends of that graph is at the same manner. It's even, either upwards or downwards. But when it's odd, it's in S form, okay? But it's positive, always remember it ends with first quadrant. Negative ends with fourth quadrant. Now, going to the zeros. The zeros, ha. Let's go to the zeros. Alright. So, let us have an example. No? Let us have an example of what could be our example. Our example, let's just say we have y is equal to x plus 2, okay, multiplied by x minus 1 squared, okay, multiplied by x minus 4. Okay. With this function, this is a function, isn't it? So, y is equal to the function. Now, first things first, as I mentioned, you have EB, zeros, this one, you have EB, zeros, and multiplicity. Now, for the EB, look for the end behaviors. How are you going to know if it's upwards or downwards? That is the thing. No? So, in first place, in order for you to know if the end behavior is facing upwards or downwards, first of all, you should know what is your highest degree with that function. What is the highest degree? A while ago, we talked about this one, Oh, we could clearly see that you have three factors. Okay, you have the first factor, which is x plus 2. This way, I'll just change the color. We have the first factor, which is x plus 2. The second factor is x minus 1 squared. Then the third factor is x minus 4. Okay. For these three factors, I will be questioning you, what is the highest degree of all factors? No? So in totality, what's the highest degree of that function? That is only one function. So in the first term, in the first factor, we have the highest degree of 1. Okay. How about in second factor? The highest degree of that one, we talked about that one a while ago. The highest degree of that one would be 2. Okay. How about in the third factor? What is the highest degree of that one? The highest degree of that one would be 1. Okay. So, knowing that, this is the thing. Knowing that the highest degree, the highest degree of these factors, we could have 1, 2, and 1. No? Now, from this highest degree, if we are going to total it, because you are going to multiply, isn't it? If you are going to multiply a variable, you are just going to add. So, you are going to add them also. Having this highest degree of each factors. Now, my question is, from the totality for this whole function, what is the highest degree of that function? The highest degree of that function is 4. Okay. So, it could be x raised to 4. Okay. It could be x raised to 4. And you know that it is 4. My question is, is it positive? Is it even or odd? It is even. Okay. So, it is even. So, we said that in table, this is our table, if it's even, it is both showing, both end of that graph is showing most likely upwards or downwards, isn't it? But this is the question. From the factors, from the factors that we have, we only have positive x, and positive x. For the first term, Now, this is my question. We got here as x raised to 4, isn't it? Because there are no such negative x's. So, we could clearly say that it is positive. Okay, so when we say it is positive, okay, so we could clearly say that the graph of that function is ending with the first quadrant. Okay, it ends with first quadrant. So, this is the thing. um, from the EB, we are done getting, no? We are done getting the EB. Now, let's just go to the zeros. So, for these zeros, what are we going to do in here is that each factor, ha, alright, each factor, this way, alright. Each factor, we are going to get the values of it from the ZPPP or zero product property. If you say zero product property, in order for us to get the value of excess, no? In order for us to get the value of excess, is that we are going to what? Have it just like this. What is the first factor? Our first factor is x plus 2, okay, x minus 1, and x minus 4. Okay? So, in these three factors, no, if we say ZPP, that is zero product property. So, in this case, we are going to what? We are going to equals it with 0. So, if you are going to equals it with 0, we're just going to input, ha? Okay. This factor is equal to 0. Okay. Now, in order for us to get the value of excess, what are we going to do? We are going to transfer the number or coefficients that we have, isn't it? So, in the final answer, what is the value of our x for the first factor? For this first factor, the value of that one would be x is equal to what? Negative 2, of course. How about the second factor? What will be the the value of x for the second factor? The value of x would be positive 1, of course. X is equal to 1, isn't it? So how about in the third factor? Oh, we're going to move that 1 to the other side, so it will become x is equal to 1. Okay. So let us have this 3, ha? Okay, let us have this 3. Okay? Sige po. So, we could now input in the graph. So, let's just have 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, 4. 1, 2, 4, 5. 1, 2, 3, 4. Alright, so let us use this color. So, in your first factor, no, it's x is equal to negative 2. So, what are you going to do in here is that you plot first where is your excess, no, or the values of x, no. So, the value of the first term or the first factor is x is equal to negative 2. So, you will be inputting or plotting the value of first factor. Okay. So, as we put the first factor, you're going to input as well the other factor. So, second factor would be x is equal to 1. So, you are going to input x is equal to 1. Good. How about the third factor? The value of the third factor is x is equal to 4, positive 4. So, 1, 2, 3, 4. This is x is equal to 4. Okay. So, with this 3, we then input, the values of x's or the intercepts that we should know, in order for us to tell where is the graph is going. So, Sir Jay, how are you going to say that where is the graph going? So, this is the thing, ha? We are done in getting the zeros. Okay. Now, we are going to get it from the multiplicity. Okay? Multiplicity. So, what is multiplicity, Sir Jai? Multiplicity is that the degree of each factor or the multiplicity of each factor. So, in this case, what is the degree of this factor? The first factor, the first factor. I will be erasing this one already, What is the degree of the first factor? That's my question. The degree of the first factor is that x plus 2. That's the first factor, isn't it? So x plus 2 is the first factor. And the multiplicity of that first factor is m. That the multiplicity of that first factor is that m is equal to 1. Or how it becomes 1? Because the degree this factor has is only 1. How about the second factor? M is equal to what? For the second factor, it is x minus 1. The multiplicity of the second factor is squared. So the multiplicity of that second factor is 2. Okay. So for the third factor, we have x minus 4. Okay, x minus 4. And the multiplicity of that third factor would be 1 as well. Okay, so this is the thing. Maybe you are going to ask me, Sir Jai, so we are just going to depend on the degree itself. Okay, so knowing that it is in a factor form already. Okay, factor form, before you that's the thing. Before you graph something else, it would be better if it's in factor form. Factor form, yes, factor form. And with those factor form, you could simply tell whether what is the multiplicity of it with that factor. What is the multiples of that factor? Okay, that's why it is called as multiplicity, from the multiples of that factor. And knowing that from this factor, it has only one multiple. Okay, how about the second factor? It has two multiples. Oh, it is clearly shown already that the multiples of the second factor is 2. How about in the third factor? The multiples or the multiplicity of this third factor is only 1. So therefore, we have 1, 2, and 1. Okay. So going back, we are done in multiplicity. Okay, we are done with multiplicity. Now, how are we going to graph that one? Going back to the end behavior, we were able to get the first term, isn't it? By what? Extracting all the factors into just one function. Okay, so we get the first function, and we got to know that it has x raised to 4, isn't it? Okay, so from the x raised to 4, we could clearly say that it is from the even and it is positive. So the degree of that expression is even, and the variable of that, or that expression is positive. We could clearly say that if it's positive, the two ends of that graph is raising are just the same, isn't it? Raising the same manner, no? So if it's raising upwards, it's raising upward. But we said that if it's positive, it ends with first quadrant. So if it ends with first quadrant and it is even, no, we could clearly say that the other end of that graph is facing upward as well. Okay. Now we now know that we are going to start coming from the top and going to the bottom. Now, your question is, so Sir Jai, are we going to just input just like this? Are we just going to input just like this? Okay. Oh, this is the thing, ha? This is the thing. So, in this case, we are not just going to do like that one, ha? So, coming from the top, this is your initial point, isn't it? Now, from the multiplicity that you have, m is equal to 1, okay? If you have 1, isn't it? If you have 1, m is equal to 1, isn't it that I told you that there are kinds of graph, isn't it? That if you have an expression of x raised to 1, x raised to 2, x raised to 3, do you remember that one? Okay, or x raised to 4. If it's x raised to 1, what is that? What is the form of that graph? Isn't it that the form of that graph is just a straight line? Okay? If the multiplicity or the degree of your expression, no, is 1 only, therefore it only shows that it is a straight line. So that is the first property, and always remember in graphing, no, there are only three things to remember. The first degree, which is line only. The second degree, no, the second degree or even, no, it is a curve or bell shape. If you say bell shape, just like this one, or just like this one. And the third one is the odd. So it forms as S shape. S shape. Okay? So, or zigzag. So those are the three components in graphs. No? So if we have the multiplicity, multiplicity of 1, multiplicity or the degree of 1, so the property of that one is just straight line only, isn't it? The property of that one is only a straight line. Okay? If we say that it is straight line, so therefore coming from the top of your graph, isn't it that this is your graph? If this is your graph, you're just going to make a straight line going downwards. Oh, maybe you're going to tell, yes, Sir Jai, isn't it that you told us that if it's positive, okay, uh, if it's the degree of 1, we're just going to make a straight line. That's correct. But if it's uh, negative, okay, if you are going to say positive, it always ends with first quadrant. But if it's negative, you're going to end with fourth quadrant. No? But how is that one? You just started with second quadrant, then you're going to fall among the third quadrant. Oh, I want you to remember this one. No? In graphing, uh, this is a sometimes if you are going to graph, there is a vice versa, no? And you should consider that in a graph, it depends as well from the function itself. For example, this function, this is one function only, isn't it? Okay, that is one function. And from that one function, how many factors do you have? You have 3 factors, isn't it? So, it only means that the graph that you are going to graph, okay, is going to be dependent to the other factors. So, it means you're not going to graph only one graph. Only one graph. Oh, yes, only one graph. Because in multiplicities, the one that I taught you, no? Okay, so let me erase this one. Isn't it that in multiplicities or the functions, the expressions that I told you with the graph, no? If you have the first degree, we're going to make a straight line. But if you have the second degree, you're going to make a curved line, no? But if you have the third degree, you're going to make an S, or in the other ways, isn't it? Whether it's positive or negative. So, it only means that there is three characteristics. But if you're going to graph one expression only, no, one expression, you are just going to graph it just like this. Okay, just like this. Only one graph. But if you have x, no, x1 and x squared, you are dependent. If you have the function, it's just the same. For example, just like that one, if that is the case, you are dependent, or this is the case. This is the case, function. You have two graphs. So that is the combination of straight line and a curved line. So it may fall on that the graph of yours would be just like this. That is two expressions already, isn't it? So it may fall on that your graph will be just like this, and you will be creating a bell curve. Okay? So could be like that. So in our case, we have three factors. So in our three factors, the first factor that we have, the multiplicity of it, is 1. So what's the characteristic when we have a degree of 1? The characteristic would be what? Straight line, of course. It will be straight line. So you are just going to create a straight line. Oh, don't don't think of it that it's really perfect. Pardon with the drawing. So let's just think, let's just say that my drawing is a straight line already. For example, straight line. Straight line. For example, that's straight already. Now, we're not going to end up until the lower part, because we also have the second factor. So, in second factor, the multiplicity of it is 2, and we have the second degree. No? If you say multiplicity of 2, we could clearly say that the multiplicity or the degree itself is 2. So, how is the graph of 2? Oh, if it's 2, what is the graph? Isn't it that it is a curved shape? Isn't it? So, if we say it's curved shape, we are going to perform a curve. Are we going to connect just like this? Are we just going to connect just like that? No. Why? Why are we going to say that it shouldn't be just like that? Oh. Why? Oh. The reason of that one is that we are going to perform this one, in straight line, in the degree of 1, isn't it? The degree of 1, this word, the degree of 1, you are just going to perform a straight line. Touches with the intercept, or x-intercept, or axis, no? So, the straight line should touch your axis, or the point where it should belong. But in degree of 2, isn't it? If this is your graph, it could be just like this. It should touch the axis, or the point that you are referring, or the point of reference, or the other way around. Okay? So it means, if this is your point, it only means that the end of your curve should touch the point itself. So going back, if this is the case, it shouldn't be just like that. It should be, it should be just like this in a curve of a manner, or just like this, isn't it? Okay. So, are we going to pursue just like this? Of course, we should connect this to, But the question is later, up until where? Is it until here, or until here? Or later on, we will be clarifying that one. Okay. So, in this case, we have the third factor, So, we started in here, to the third quadrant, going to the point, then going downwards, okay? So, if we end up with downwards, we are going to end up with downwards, there you go. Now, you end up with downwards, you are going upwards because this is the last or the end of your graph, isn't it? So what is your third factor? The third factor, the multiplicity of it will be 1. And if we say 1, no, if we say 1, it is just a straight line. So coming from the initial point, you ends with this part, isn't it? Because the bell curve ends in the bottom. So you're going to start it with the bottom going to the top. So you are going to perform a straight line. Straight line. Okay, so that is your graph. Now, this is the thing. Sir, it is cutted and we don't see any connections between the two. Now, this is the question, sir. How are we going to know what part of the y-axis are we going to uh, graph the the graph of that function. So here's the thing, ha. I'll be erasing this one. Okay. All right. So we have the function of x plus 2. We're not going to erase this one, ha. And x minus 1 squared multiplied by x minus 1. Alright, so with this function, no, isn't it that, what else one? Isn't it that we were able, no? We were able to get the multiplicities, okay? And we were able to get as well the factors, no? Or what else one? The factors of the zeros, or I'm sorry, or rather, we also get the zeros, no? The values of x's, okay? Alright, so if you have the graph, if you have this graph, I'll be circling this one. If you have this graph, isn't it? This is your graph, isn't it? Now, may I question you? From the values of x's a while ago, where did you point it out? You point it out with x. Oh, I will be changing this one. X is equal to negative 2. This is for first factor, isn't it? For the second factor, it will be x is equal to 1 and x is equal to positive 4. Okay? There. Alright, so having that one, no, we could clearly say that these are your points. So if in number line, it will be just like this. This is your 0, this is your negative 2, and this is your 1, and this is your 4. Okay? So in this case, no, in this case, if this is the two end points, points. Yes, you have point in the middle. This is the question. What is the highest degree? Once again, what's the highest degree of this function? The highest degree of this function is x raised to 4, isn't it? And if it's x raised to 4, isn't it? That if it's even, it performs just like this in a graph, isn't it? So it only means that you have two end boundaries of that graph, no? So you have two end boundaries. Now, if these are the two ends, the two end points, or the points wherein the graph lies, no? How are we going to know up until where? That is the question, isn't it? Now, this is my question. From negative 2 up until positive 4, what are the numbers inside, no? Inside or between those two numbers? From negative 2 and positive 4, what are the numbers between them? So we have the numbers of negative 1, 0, 1, 2, 3. Isn't it? Okay. So, we got the positive one, isn't it? Okay, we have the positive one. So let us try, this is the thing, let us try to know where would the graph would go if it's negative 2. Oh, we clearly say that we graph it, no? So there is a straight line coming from, as well as positive 4, there is straight line, as well as for positive 1. So what are the numbers that we are not yet using? So we do have negative 1, 0, and 2 and 3, positive 2s and 3s. Now, let us try to use, no? Let us try to use the negative 1 and positive 3. So, let us use, negative 1 and positive 3. So, coming from the negative 1s and positive 3, let's just substitute the values of negative 1s and positive 3s to the values of x's. Okay? So, if we are going to substitute the values of negative, if we are going to substitute all x's with the value of negative 1, it will become negative 1, positive 2. Okay, that is your first factor, isn't it? And this is your second factor. Okay, squared. And negative 1 or negative 4. Alright, so this is your first factor, isn't it? Second factor and third factor. And if you notice, all x's becomes negative 1. All x's becomes negative 1. Alright, so that's how we do it, no? So let us try. If we are going to substitute it, no, what will be the totality of what will be the answer for that function? No? So we could clearly say this is the function, no? Y is equal to this function. So we could clearly say that this is the function. So y is equal to what? Negative 1 plus 2, what will be the answer? The answer is positive 1. Correct. Positive 1. How about this factor? This is for the second factor. How about the second factor? Negative 1. Negative 1 minus, no? Minus 1, what will be the answer? Negative 2. Negative 2. But don't forget there is a square. So it will be squared. Now, we have the third factor. Negative 1 minus 4. What will be the answer? Negative 1 minus 4. The answer is negative 5. Okay. So, in this case, we know that any number that is multiplied by 1 is the number itself. So, we could clearly clear this off, no? Because even though you multiply it in any number, the answer is the number itself. Okay, so in this case, we have the second factor, and the third factor. No? So, in second factor, we have the square of it. No? So, if you're going to square the negative 2, what will be the answer? Negative 2 times negative 2, isn't it? So, the answer in here will be positive 4. And if you have positive 4, and you only have positive 4 and negative 5, the answer in here is that it would be negative 20. So, your y would be negative 20. When the value of x is negative 1. Okay? Your y would be negative 20 when the value of x is negative 1. Okay? So, that is for the case for negative 1. What if we use, no? What if we use the values of positive 3? Okay? What if we use the value of positive 3? Okay. So, let us say, for a different color, let's just say that it is positive 3. Positive 3. Positive 3. Okay. So, your function, your y, would be equals to 3 plus 2. The answer is 5. Correct. How about this second factor? 3 minus 1, what would be the answer? The answer would be, correct, 2. No? But don't forget there is square. Okay? Now, for the third factor, you have 3 minus 4. No? So, 3 minus 4, what would be the answer? The answer is negative 1. So, in this case, you have the exponent still for the second factor, isn't it? So, 2 times 2 or 2 squared is 4. Okay? So, knowing that it is 4 and you have the first factor which is 5, 5 times 4, the answer would be 20. Okay? And you still have the third factor which is negative 1. So, 20 multiplied by negative 1, what will be the answer? The answer is negative 20. So, we could clearly say that the values of this function, when the function is negative 3, positive 3, the answer is negative 20. Or we could clearly say that this one, I'll be changing the color. So we could clearly say that when the function of x is equals to, the function of negative 1 is equal to, the function of x is equal to negative 1, the function would be negative 20. And when your f of x is equal to f of x, when you have the function of 3 or positive 3, your function would be negative 20 itself. So, search how it happens. No? So, from the values itself, it only shows, that that is the other point where the graph touches. So, it means that this point that we have in here, isn't it? So if this is our y-axis, for the first function, which is negative 1, this is your negative 20, for example, negative 20. Your graph will touch to your negative 1 up until negative 20. So your graph would be just in here. Okay? So same goes by for the positive 3, it will become negative 20. So negative 3 up until negative 20. So your graph will touch until negative 20. Gets already? And with that, you could continue to the graph for the second multiplicity. Alright, so therefore, in that case, you could also graph. No? You could also graph and substitute the values of 0 and 2, and you could clearly see that the points of that one will be ending up in here, and for the positive 2 will in here. So it shows that in each point, there is a specific graph where the point or the graph will be touching, and it shows the point itself. Okay, so I hope that somehow you could see and clearly see what are the differences between when you are going to graph it with the multiplicity of 1, whether where are you going, where it comes from, you are going to show what are the three things: the straight line, or the curved line, or the zigzag form. Okay, so for the next meeting, or some of you maybe we're done already in with the things that you should be dealing, like the theorems, fundamental theorems of algebra. I hope that you can now cope with graphing of polynomials. Okay, so there are other ways around. With regards to, for example, when the graph is negative, or when the whether the graph is negative, or whether the graph is odd. Okay, so in conclusion, with this graphing, isn't it that I also mentioned to you that when we have I'll be erasing this one. When we have I will just add slides. Wait. Alright. So when we have a uh, positive, when we have a negative, negative expression and odd, odd expression, the graph itself will be just like the other way around, no? If you see, if you see from what we did a while ago is that it is x raised to 4. It's x raised to 4, isn't it? I showed you that if you have x raised to 1, x raised to 2, x raised to 3, isn't it? So we come up with the same manner. It's still even, no? And I showed you that the lower the even number for your degree, the steep, the steeper it looks like, no? When or the pointer it looks like. But when the uh, when the degree or the exponent is becoming larger, or it comes with x raised to 6 power, if you have if you have the graph of this one, isn't it that this is your x squared? Okay, and you have you have let's just say this way. If you have the graph for the x to the 4th power, what if you have yan, okay. If you have the expression of x raised to the 4th power, it may looks like a flatter, um, it may looks like a flatter graph, no? And even if you increases the degree, in an expression, most likely in even, no? For example, it will be x raised to 10. The flatter it becomes. The flatter it becomes. No? So the wider it becomes. So in conclusion, if you will notice this graph that we made, it may look like no, just like this. No? But in conclusion, if you will notice, this form or this graph forms just like this. Isn't it? It forms just like this. Okay? It forms just like this. Okay? So, if we are going, no? If we are going to, uh, have all the points inside the negative 2, no? And negative 4, negative 2, and positive 4. If you use all the points inside that graph, no, you could end up with making one of this. You could end up with making one of these graphs. Okay, so it is really important to have the values of x by using the zero properties or zero product property, no? And what are the things? What are the things, no, that we should know, or what are the dependent things in order for us to have the final graphs? Because if this is your points, yes. This graph has this point, isn't it? And this point are equals to that point, to the x-axis. So it serves as that every point inside that graph that it touches, no, it correlates with the axis itself. So that is one thing around. No? So in deeper math, it is somewhat spectacular. We're going to discuss that one. But in basic graphing, no, you should always depend as well, always in the between or the middle of this, not really middle, the numbers between these two endpoints that you have in your function. So I hope, in conclusion, I hope that for this graphing, it is somewhat clearer and you now see how is the graph for these polynomials are working, no? And how are we going to know until when are we going to form a curved line on the bottom, no, of the graph, no? And I do hope that um it would be better, no? It would be better as well if we try different expressions for us to graph. Okay? So with that said, I do hope that for the next meeting, we'll be tackling about fundamentals. For those who are not yet, no, we will be tackling about the fundamental theorem of algebra. And with that said, we'll be closing this um, recorded video. And I do hope that you learned something with regards to graphing, and it's now clearer. And with regards to the expressions, most likely in multiplications, I do hope it was clear and it was corrected already. No? And there's no confusions with regards to that one. Alright, so without any further ado, no, let's close this record, and I do hope that you really learned that. Alright, so thanks for once again, grade 10, for watching this recorded video, and see you next session. Bye.